Ever tried to debug a complex workflow by peeking into its exact state at any previous step? You'll see how LangGraph's persistence system lets you fetch complete state snapshots using just a thread ID, or target specific historical checkpoints by adding a checkpoint ID. The return state snapshot objects contain full execution context, including values, next steps, metadata with step information, and even pending tasks, all officially documented in the persistence examples.
Hash get the latest state snapshot. Config equals configurable, threaded, 1. Graph get state config. Hash get a state snapshot for a specific checkpointed. Config equals configurable, threaded, 1. Checkpointed. 1F663 ba 28 fee 6528 8002 5 A 559,208,592 C. Graph get state config.
This demonstrates the state checkpointing pattern for persistent workflow execution. The concept centers on capturing immutable snapshots of a graph state at each logical step, enabling precise state inspection, time travel debugging, and fault-tolerant recovery. The distinctive aspect is how it treats state persistence as a first-class capability through standardized checkpoint identifiers and thread-based organization, rather than an ad hoc serialization mechanism. The pattern operates by instrumenting the graph execution engine to automatically generate state snapshot objects at each superstep, storing them in a thread-specific timeline. Each checkpoint contains the complete state values, execution metadata, pending tasks, and lineage information through parent config references. Retrieval works through a consistent configurable pattern, where threaded identifies the execution timeline and optional checkpointed pinpoints specific states. The getState and getStateHistory methods both use this identical config structure, returning state snapshot objects that include values, next operations, metadata with step source information, and any pending tasks or interrupts. This approach solves critical challenges in stateful systems where durability and inspectability are requirements. It enables precise debugging through checkpoint replay, supports human-in-the-loop workflows via state inspection, and provides fault tolerance through recovery points. The trade-off of increased storage is justified for systems needing audit trails, interactive oversight, or recovery capabilities, such as agentic workflows, approval chains, or collaborative processes. The pattern's strength lies in its standardized interface that works identically across memory, SQLite, and Postgres backends, while maintaining separation between state persistence and business logic. Let's break it down.
Config equals configurable, threaded, 1.
This config dict follows the documented getState pattern, specifying a threaded to fetch the latest state snapshot. The nested configurable structure matches the official API examples in persistence. MD, where both threaded and checkpointed are supported parameters for querying state history. When combined with checkpointed, as shown in the next call, it retrieves immutable historical snapshots containing full execution context, including tasks, interrupts, and memory writes, with parent config tracking checkpoint lineage.
Graph get state config. Hash get a state snapshot for a specific checkpointed.
This fetches a state snapshot for thread 1 using the documented getState method. The first call retrieves the latest execution state, while the second targets a specific historical checkpoint via checkpointed in the configurable object. Both patterns shown in persistence, MD examples. Each snapshot contains full execution context, tasks, interrupts, memory writes, and checkpoint lineage through parent config. The checkpointed parameter enables precise time travel debugging by referencing immutable points in the thread's linear history.
Config equals configurable, threaded, 1. Checkpointed. 1F663 ba 28 fee 6528 8002 -5 A559,208,592C.
This config dictionary follows the documented pattern for retrieving a thread state at a specific checkpoint, using both the required threaded and optional checkpointed parameters. The checkpointed enables precise state inspection by referencing immutable points in the thread's execution history, with full support shown in the official persistence, MD and add memory, MD documentation. The returned state snapshot includes complete execution context, tasks, interrupts, memory writes, and metadata, with parent config, showing checkpoint lineage for debugging or state restoration.
Graph get state config.
This fetches execution state snapshots from a LangGraph graph using the documented configurable pattern. The first call retrieves the latest state for thread 1, while the second targets a specific checkpoint by including its checkpoint ID, both officially supported parameters shown in persistence, MD examples. The returned state snapshot contains full execution context including tasks, interrupts, and metadata with step history, source information, and writes, enabling time travel debugging and state inspection through the immutable checkpoint lineage. LangGraph state management pattern. The config dictionary with its configurable key provides thread isolation and temporal state access, using threaded for thread scoping and optional checkpointed for targeting specific execution snapshots as documented in persistence, MD. The getState and getStateHistory methods both accept identical config structures, returning state snapshot objects that include values, metadata with step right source details, parent config lineage, and task interrupt status per the official API documentation. Always verify checkpoint existence in production workflows, as the checkpoint lineage in parent config reveals the complete execution path through checkpointed and checkpoint NS pairs.
The checkpoint that never changes holds all futures.